Mclag, or multi-chassis link aggregation group, is a type of link aggregation with continuant parts that terminate on separate chassis, mainly for the purpose of providing redundancy in the event one of the chassis fails. After reading this purpose of Mclag, you may immediately ask, then why not STP? Because STP can also achieve redundancy. So in the later part of this Wikipedia article, it mentions the Mclag is superior to STP because the load can be shared across all links during normal operation, whereas STP must disable some links to prevent loops. And STP also has a disadvantage. It's about the delay when recovering from failure. It has much longer convergence time. In this video, I'm going to use two Ubiquiti ECS-Aggregation switches to configure Mclag and to do some demos. Thanks to Ubiquiti for sending me these two switches to make this video possible. I'm gonna cover this topic in two videos. The one you are watching is about general configuration and demos. I'm also going to have another video for deep dive. We are going to see how it's configured and use Wireshark to see how Mclags work and how regular link aggregation works when connecting to Mclag switches. Let's see one of the benefits in action, the support of devices which only support regular link aggregation instead of Mclag. I have the top and bottom two ECS aggregation switches. I already configured Mclag, and then I have two Mac machines. Each of them has 10 gigabit RJ45 already, but to enable link aggregation, I use a separate external Thunderbolt adapter so that I can achieve link aggregation for each Mac machine. Then I connect the links to the two ECS aggregation switches. Let's see whether the Mac machines can establish link aggregation successfully, and if one of the switch fails, what's the impact to ongoing network communication. Yes, I even haven't shown you the Mclag configuration in UniFi network application yet. Later we will talk about this setting in more details, but for now let me simply show you the setting for regular devices. I already have a Mclag group configured, and there are multiple target device memberships configured already. This 35 is for the left side Mac Mini. The 36 is for the right side Mac Studio. If I go to 35, you can see it's very simple. So I use two parts in total. The first part in the top switch, the second part in the second switch. And for the target 36, similar situation, 36, 36 in the two different switches. So you can see it's different than your regular link aggregation, right? The two parts are in two different switches. Then let's see whether it works or not. In the lower part, for the left side Mac Mini, you can see I already configured a bound interface. It supports link aggregation. Then if I go to details, you can see it includes the built-in 10 gigabit Ethernet part and a external Thunderbolt to Ethernet adapter, and their links are both okay now. In the right side for the Mac Studio, if I go to the bound interface details, similar situation. One of the built-in 10 gigabit Ethernet part plus a external Thunderbolt to RJ45 adapter. Click on one of the ECS aggregation switch, go to port manager. You can see 35, 35, 36, 36. They are all showing blue color, and from the icon you can tell they are configured as link aggregation. Now everything's ready. Let me start testing to prove that yes, I do have a link aggregation working for both devices. In the left side Mac Mini, let me run iPerf3 server. Then in the right side Mac Studio, let me first run iPerf3 in this way. Use the left side Mac Mini as a server, and I don't specify any other parameters. You may know by using this parameter, the iPerf3 will only use one connection. So let's see what's the maximum speed. Okay, see, it's just close to 10 gigabit. we see no effects for link aggregation. You know why? Because there's only one connection, and link aggregation is not magic. If you only have one connection, it doesn't help. You can only achieve one of the link's maximum speed, right? So to fully utilize link aggregation, you need to have multiple connections. So let me run the command in this way. Let me specify 10 parallel connections. Okay, see the effect? Now I have 19 gigabit per second. And this is just result for one direction, which is uploading or sending. Let me test both directions by specifying bi-direction. You can see for both connections, I can achieve 18 or 19 gigabit per second. Perfect speed. Now you see the effect of link aggregation. It works by connecting one link to each of the two ECS aggregation switches. Okay, we are not done with this testing yet. Let me show you another benefit. If you lose one link, the two computers can still communicate with each other. So to simulate that, let me click on the ECS aggregation bottom switch, go to settings, and let me restart the switch. Before restart, in the lower part Mac Studio, let me start a continuous testing running for a long time. It's running, right? Then let me restart one of the switch to simulate a network issue. Restart. Okay, see the effect? Now the switch has been restarted. Some of the connections were broken, but some of them are still working. So that's why in total, for each direction, you still see 10 gigabit speed, and the connection is still going on. Basically, there's no interruption in the communications to computers at all. I can still achieve the maximum speed for one of the two links. Now you see one of the benefits work in action. Next, let's talk about the configuration for this video. To configure Mclag is not very easy. The reason is, unlike the regular link aggregation you are familiar with, for Mclag, you need to worry about not only the member links from other devices or switches, but also the communications between the two ECS aggregations. And to make it even more complicated, if you have the EFG with shadow mode configuration, like what I have in this lab environment, it will make the configuration more complex. Just look at this already simplified diagram. You can see it's a little bit messy, right? So many links you need to connect. So in the lower part, I show you the UniFi document. This is a very clear, very good document. It even listed in different upstream connection scenarios how you can configure the Mclag differently. In my case, I'm following this one, the EFG with shadow mode. So you can see there are a lot of steps. Trust me, it's very easy for you to make minor mistake, then make the whole configuration not working. However, after you validate the setup works, if you go back, revisit all the links, all of a sudden you will realize everything is so apparent, so understandable. In the UniFi network controller, you can see in this lab environment, I have a EFG. If you check the control plane, you can see I do have a shadow EFG configured. It's ready to take over. So I have two EFG devices. They use a UniFi 1 switch to connect to internet. These three devices are the uplink devices. I also have two example switches just to demonstrate the downstream switches. You can see they are also connected to the two ECS aggregations using link aggregation, right? And then to make the whole setup work, you see the red ones, these two links are crucial. They connect these two ECS aggregations together. So basically in this setup, we are talking about three different types of link aggregation connections. They work together to make the whole setup work. If I go to either of the ECS aggregation switches, go to port manager, you can see there is a special tab which doesn't exist for other switches, but for this ECS switch, you have a new tab called Mclag. Click on it. Here you can see I already configured a Mclag group. So the purpose of Mclag group is to act as a logical container. You configure not only how your two ECS aggregation switches connected, but also you configure the so-called target membership. For example, these two switches in this demo. And for another example, these two EFG in this demo. So in the whole logical container, which is the Mclag group, we need to configure them all. Now let me click on the already configured Mclag group 1. You need to specify which one is the top switch, which one is the bottom switch. I only have two ECS aggregations, so I specify them accordingly. So then this option is a little bit misleading. It says stacking, but what it really does is simply to determine whether the system will show the two switches parts in the same screen or not. Let me show you visually what it means. So let me disable it. Then if I go back to the switch, see, now you only see one switch, right? So let me show you the difference. Enable it back. Now you see two switches. So this is what the so-called stacking really means in the UniFi UI. The next option is crucial. It specifies the multi-chassis link. In this link, we need to indicate the member interfaces from each switch, the top switch and the bottom switch. It is a peer link. The important ICCP communication to enable the Mclag will be done through this link. We will talk about the technical details in next video. These two red ones between these two ECS aggregations, they are crucial in this setup. Yes, they are still kind of link aggregation, but they are for totally different usage. They are peer links. If I click on the details, you can see I simply specify two parts from top switch, another two from bottom switch. And in my setup, I chose the 100 gigabit part, the QSFP28 parts. In the lower part video, you can see the rightmost side four very thick cables. They are the DAC cables. Each one of them is 100 gigabit. The next step is to set up so-called target device membership. In fact, what you are really setting in this particular section is just the link aggregation. The only difference if you compare to regular link aggregation is the endpoint. One is in top switch, the other one is in bottom switch. That's the difference. So for example, if I choose the one, each of them is from an individual ECS aggregation switch. This particular target device membership is for the primary EFG. See, from this primary EFG, I have two links connected to the two switch, right? This is what the one for. And the two is for the secondary EFG, the HA-EFG. And then 28 is for this left side USW Enterprise 24 switch. And the 41 is for the right side Enterprise XG24 switch. 35 and 36, they are used by other use cases. I use them to connect to computers instead of switches. But the link aggregation is established in the exact same way as the two switches. So far, you already observed the three different link aggregations. First, the multi-chassis link between the two ECS aggregations, these red ones, right? And then another type is for the upstream connections to the EFG and the shadow EFG. And the last type is the regular link aggregation from switch or from your computers. So there's one thing I want to mention here is the number 2. See the diagram? Number 2 is connected to the HA-EFG. So what you see here is showing gray color. There's no any text here. And if you go to parts, you can see part 2 for each switch is showing STP blocked. This is the display based on the current UniFi network application. Just for comparison, let me show you a screenshot I took for previous version. So you can see there are 3 columns. The third column is status, and for the part 2, the status says not established, and there's a warning sign. So in fact, the port 2 is showing gray color. That's understandable because it's connected to the second EFG. At this time, the second EFG is not active, right? However, the status text is very confusing. It makes you think something is wrong. In this version, apparently Ubiquiti hasn't come up with a better description for the status for port 2, but to avoid the confusion on the UI, Ubiquiti decides to completely hide the third column, which is the status. Next, let me briefly show you the link aggregation setup on the EFG and the two UniFi switches. So go to EFG. For port manager, you can see port 5 and 6. They are configured as regular link aggregation. This is the benefit of using EFG because you can configure link aggregation. Therefore, you have the chance to connect it to ECS-Aggregation to utilize the benefit of Mclag. Then for the switches, for example, this Enterprise XG24, in a similar way, for port 25 or 26, you can see I configure link aggregation. There's nothing special in this client side or switch side link aggregation configuration because they are not aware of the other end is ECS aggregation switches. They configured Mclag. No, they have no idea that's the case and they don't need to know that. That's the benefit of Mclag. It can support regular link aggregation transparently. In the last part of the video, let me show you two more testings. First, I have two client machines. They are in the same VLAN. They are directly connected to different UniFi switches, and these two switches are both link aggregated to the ECS aggregation switches. What I'm going to test is what if one of the ECS aggregation switches, if it's down, whether the ongoing communication between the two client machines, whether it will be impacted or not. Because they are in the same VLAN, the router, the gateway, is not a factor in this testing. And the second testing is what if a EFG is down? I connect the two client machines to different VLANs. So whether the communication will be impacted or not. Let's get started. So in the lower part of the screen, I show you two client machines. For the Linux client, let me show the IP address. Okay, it's in VLAN default. Then from the Mac machine, let me ping the right side Linux machine continuously, and I specify the interval to 0.1 second. The reason is I want to ping it as frequent as possible so that we can accurately see whether the connectivity is impacted or not. Okay, let me start the ping. Then from the UniFi network controller, let me simulate a switch down. For example, for this top ECS aggregation switch, if I go to settings, I force a restart just to simulate a switch down. Restart. In the meantime, let me go to port manager, show you the Mclag. You can see at this moment, the 53 to 54, this multi-chassis link is still showing green, right? Let's give it some time. So once this green link is done, let's see whether the ping is impacted or not. You see some brief interruption, right? You see the multi-chassis link is down, but in the ping, you can see it's still going on, right? So depending on whether the packet goes through this link or this link. If it happens to go through this link because the switch is down, maybe this packet will be impacted, right? So depending on that particular situation, it may or may not cause interruption. But even if that happens, the interruption is very short. As you saw, it was less than 1 second in our case. It's much faster than STP convergence. Once the top switch is down, all the traffic is supposed to go through the bottom switch. The ping is still going on. Then give it some time. So let's see once the multi-chassis link is going back to green, once the switch is restarted, let's see whether the communication has any change. You see some interruption again. Okay, now the multi-chassis link is back to green and the ping is going on, right? We see very short, less than 1 second interruption. Let's move on to next testing. At this moment, everything's working fine. The multi-chassis link is showing green and all the EFG and the switches, they are on. If I simulate a EFG down, it should fail over to the second EFG, right? Let's see whether these two clients' communication will be impacted or not. In the Linux machine, I already changed its VLAN. Let's validate it to see the IP address. You can see it's in subnet 10. Then from the Mac machine, it is still in default network. Let me ping the right side Linux machine. I'm still using the 0.1 second interval. Let it run. Then in UniFi network controller, for the primary EFG, in settings, let me restart it just to simulate a EFG down to force the failover to the second EFG. Restart it. You can see the failover is happening now already. Yep, you see the interruption. For the failover of gateway, it will take much longer time than the Mclag failover. It may take many seconds, so give it time. Now the second EFG is trying to take over. Okay, the second EFG is taking over and you can see the ping resumed and then broke and then resume again. By the way, you can see the whole taking over process took more than 2 minutes. Now you can see the two EFG situation, the shadow gateway, it says failover activated. And now you know what happened because the first EFG, the way I simulate a failure is by restarting it, right? Now it's being restarted, so the system is fading back to the primary EFG. So that's why you see this screen again. Okay, you can see the failing back has been done. Now the original primary EFG is back and is active now, and the shadow gateway is becoming the shadow gateway again and is ready to take over. Now we are back to the normal situation. So in the whole process, the network communication between the two clients were broken for about 2 minutes, but that super long time was not due to the Mclag between the two ECS aggregation. No, it's simply due to the EFG failing over. Okay, this ends the video. Thanks for watching.